Alright everybody, welcome to our third and final video tutorial on rational expressions. In this video, again, we'll be adding and subtracting, but now we're going to have polynomial denominators in our rational expressions. So, again, let's just dive right in, trial by fire, and let's do our first example. Let's say we've got x minus 1 over x squared minus x minus 6, and then we're going to subtract 4 over 5x plus 10. Okay, again, just like before, we're going to find our LCD. Now, when we learned how to do this in part 1, our first step was to factor each of our denominators. Okay, well, nothing's different here. We're going to factor both of these. So let's bring down our x squared minus x minus 6. Let's bring down our 5x plus 10. Over here, factors of negative 6 that add up to negative 1. Well, that's not so bad. That's x minus 3 and x plus 2. Over here, the only thing we can do to simplify this is to take a 5 out, leaving us with x plus 2. So our LCD is, again, each factor written however many times it appears. So let's look at 5. 5 appears once and none. So the most of the times it appears is once, so that's how many times it appears in our LCD. Now, x plus 2, it appears once and once. So again, the most it appears is once. Well, that's how many times it's going to appear in our LCD. And then x minus 3, once and none. So it is going to appear once in our LCD. So this right here is our LCD. Now, here's the trick. To figure out what we need to multiply our denominators by, let's rewrite our problem in factored form. So let's go x minus 1 over, let's rewrite it in our factored form. So this becomes x minus 3 times x plus 2. Okay, we just brought our factored denominator, replaced it down here. And then minus 4 up top over here over, just bring down our factored form, 5 times x plus 2. Okay, so here's our new problem. This is our current step that we're on right now. So, just like we did in the last part, what do we need to multiply this denominator by to get to our LCD? Well, if we look x minus 3 and we've got an x minus 3, well, we don't need to multiply that by anything. X minus 2 and x minus 2, well, we've got that covered. The only thing we're missing is a 5. So we have to multiply over here the top and the bottom by 5. Now, over here, we've got the 5 covered in this denominator. We've also got the x minus 2 covered. What we're missing, though, is the x minus 3. So over here, we've got to multiply the top and the bottom by x minus 3. Okay? So, doing this arithmetic, distributing this 5 into this x minus 1, you get 5x minus 5 over our LCD, which is 5 times x plus 2 times x minus 3. And now we're subtracting, distributing that 4, you get 4x minus 12 over our LCD, which is 5 times x plus 2 times x minus 3. Now all we have left to do is subtract the top. Okay, so I'm going to clear this away and make room so we can simplify that a little bit. So let's rewrite our previous step. We had 5x minus 5 over our LCD, which was 5 times x minus 3 times x plus 2. And then we were subtracting. We had 4x minus 12 over our LCD again, which is x plus 2 and x minus 3. So now what we have to do is we have to distribute this negative into each term up here in this numerator. Okay? So we're going to subtract the top and keep the bottom. So we've got 5x minus 5 minus 4x plus 12, because two negatives always make a positive. And this over our factored form, or our least common denominator. So now we just do this math. 5x minus 4x just gives me x. Negative 5 plus 12 gives me positive 7 over 5 times x minus 3 times x plus 2. And again, always check. There's nothing I can factor or cancel. So this would be your final answer.